Mastering this topic sounds complicated, but it doesn't have to be. Welcome to the channel. In this video, we're breaking down exactly what you need to know, step by step, with zero fluff. Let's get right into it.
Picture the beginning of the universe. Your brain immediately cues up a familiar scene, a completely empty, pitch-black void, interrupted by a tiny point of light that suddenly erupts outward in a massive fireball. It is a vivid picture. It's also completely wrong. Despite what science fiction movies and even some textbooks suggest, almost every detail of that mental image contradicts the actual physics. There was no cosmic fire. There was no pre-existing dark room waiting to be filled, and the event didn't originate from a single lonely dot in space. To understand what actually happened, we have to throw out the idea of looking for a starting line. Instead, we need to take the universe exactly as we observe it today, and then run the math in reverse. By ditching the forward-moving timeline and hitting rewind on the cosmos, the illusion of that giant cosmic firework finally falls apart. Look at this image of a bright spiral galaxy. In the modern universe, the vast distances between galaxies like this one and those fading into the background are constantly increasing. Everything is moving away from everything else. So if we press rewind, those galactic neighbors start drifting back toward one another, closing those massive gaps. But as they get closer together, we hit our first major departure from the popular myth. These galaxies are not traveling backward through empty space like rockets thrown into reverse. Instead, they are actually sitting perfectly still. What is shrinking as we wind the clock backward is the fabric of space itself, a phenomenon known as metric expansion. Think of space as a two-dimensional grid. If we let time run forward, the grid scales up. The physical space between coordinates actively stretches, carrying the galaxies along. They aren't moving to new coordinates. New space is simply being generated between them. The Big Bang was an expansion of the container itself, rather than an explosion happening inside a container. The universe isn't a room slowly filling up with flying shrapnel. The room is growing. Let's keep rewinding. As that container shrinks further into the deep past, all the matter and energy inside gets forced into tighter and tighter quarters, driving temperatures to unimaginable extremes. Human intuition desperately wants to follow all this compressing material down to a single location, the center point where the whole thing eventually collapses. But because all of space is compressing at the exact same time, there is no spatial center. There is no edge for it to collapse away from. Watch this dense field of particles. As it compresses, it never shrinks into a solitary dot in the middle of a screen. If the universe is infinite today, it was also infinite at the beginning, just infinitely denser. The expansion didn't happen at a specific set of coordinates. It was space itself, expanding everywhere at once. Eventually, we reach a point in our rewind where the math simply stops working. We hit a state of infinite density, and the tape snaps. Physicists call this extremely hot, dense limit a singularity. At this threshold, our current rules of the universe, specifically the laws of general relativity, completely break down. We do not have the math to calculate what happens next, which leads us to the biggest misconception of all. The Big Bang Theory does not actually explain how the universe was created out of absolute nothingness at time zero. It is strictly a description of what happened next. It outlines how a pre-existing cosmic soup cooled, stretched, and organized itself into the stars and galaxies we observe right now. What existed before that done state, or if the word before even applies, remains an unsolved puzzle in quantum gravity. This is a story of cosmic evolution, not absolute genesis. When we let the tape play forward at normal speed, we find ourselves sitting right here in the present day, riding along on that continually stretching fabric. And because space expanded everywhere simultaneously, there is a strange truth to our current position. You are currently sitting in the exact location the Big Bang happened. So is the Andromeda Galaxy, and so is the furthest quasar we can detect. If the math describes an elegant everywhere-at-once expansion, why is our collective imagination still stuck on the idea of a giant bomb going off in the dark? We can trace that back to 1949, and this man sitting at a BBC microphone, English astronomer Fred Hoyle. Hoyle was a fierce champion of the steady-state model, a rival theory arguing the universe has simply always existed without a start date. During a radio broadcast, Hoyle wanted to mock the idea that everything had a definite beginning. To dismiss it, he sarcastically referred to it as the Big Bang idea. The name was incredibly catchy. So catchy, in fact, that it stuck permanently. The theory's loudest critic accidentally branded the birth of our universe with a misleading punchline, trapping our imagination in a myth and obscuring the true elegance of how space actually works.